Hi, my name is Jonathan Carter, and in this session, we're going to talk about an exciting capability that is available to React Native mobile developers. Specifically, the ability to dynamically release updates instantly to all of your end users without needing to first submit those updates to the store. In this session, we'll talk about the CodePush service and how it can make it very simple for you to streamline your React Native app update process and more closely engage with your end users. So when we think about mobile development and how it is not traditionally as easy or as agile to release updates as, say, the web is, there's a few core reasons that have prevented that from being easier today. So first, when you think about a React Native app, in order to make it as performant and as available for the end users that have installed the app, it needs to be offline, and therefore all the code, the assets, and so forth are installed locally to each device. That has the negative effect that if a developer wants to make a change to any of their code or images, those changes won't be naturally picked up the next time the user runs the app. Additionally, because mobile apps tend to be distributed via public stores, and those stores introduce some degree of non-deterministic latency, there's no way for a developer to know exactly when an end user will actually get the update after they've made it. And this can introduce some non-ideal delays when wanting to know when a critical bug fix is available, how frequently you can test new features, or really how closely you can engage with your end users in general. So this is where CodePush comes in. So what is CodePush? CodePush is a cloud service that we released about 4 months ago that allows you to distribute updates to your React Native apps. It also supports Cordova, but for the sake of this session, we're going to talk specifically about React Native. The service itself is fully managed via a cross-platform CLI, so that no matter where or when you want to release updates, you can in a very lightweight fashion. And finally, it comes with a very comprehensive but simple SDK that you can integrate into your React Native app and ensure that the app is fully synchronized with the latest update for all of your end users. How do you get started with CodePush? It's super simple, and there's 6 easy steps that will get you started, 5 of which are a one-time cost, and then the last one you would do every time you make a change. So as I mentioned, the CLI for CodePush is cross-platform, and it's distributed via NPM. So once you've installed that, you can register an account using either your GitHub or Microsoft credentials, and then notify the CodePush server about your app, which is named whatever your app is named. Finally, you can install the SDK into your app. We recommend using the React Native Package Manager. And then you simply call a single API method somewhere in your application that is appropriate as the point that you want the app to synchronize updates with the server. Then, once the app has been fully CodePushified, all you have to do is use the CLI to release an update. And once you've done that, every instance of your app that is now calling that sync API will see the update and immediately be synchronized, making sure that any bug fixes, new features, or new capabilities that you want to release to your users are available immediately. So let's go ahead and take a look at what this looks like in action. So as I mentioned in the Getting Started slide, the first thing you need to do to get started with CodePush is install the NPM-based CLI and then register an account. In this case, I've already done that, and for this demo, I'm going to highlight the MathFacts app, which is an experimental app created by Khan Academy to help people better memorize their math facts, such as multiplication tables and so forth and so on. It's a pretty cool app that I encourage anyone to check out that I'm going to use here because it's a really good example of React Native. Now what we want to do is highlight how we can use CodePush to start releasing updates to, this case, the MathFacts app. So if we come to the CLI, you'll notice that I ran code-push to output all of the commands that are available to you using the CLI. There's quite a lot of capabilities, and we'll try to highlight as many of them as we can. But for starters, if we just come and say app.ls, I'll just illustrate that we did in fact add the app called MathFacts to our CodePush account. And I've also already integrated the SDK into the app to make it a little bit simpler for the demo. So once you've done that, the next thing you need to do is go into your JavaScript code and integrate the use of the CodePush JavaScript SDK. So here, using ES6 syntax, which is very idiomatic for React Native, we'll say import CodePush from React Native CodePush, which is the name of the module that we expose to your app once you've installed our SDK. So this CodePush object that we now have access to has quite a lot of capabilities on it as well. You'll see that within VS Code, I get really nice auto-completion on the API that CodePush exposes. And for the sake of this demo, what we're going to do is call the sync method, which has quite a lot of options that you can use to specify exactly the experience that you want your end users to get. But for the sake of this demo, what we'll do initially is we'll say we want to display a dialog to the end user whenever an update is available. And when there is an update available, we want to install it when the user resumes it from the background. So we'll say install mode on next resume. That way we won't immediately interrupt them at the time, but we don't wait until the next app restart either. It's kind of the best of both worlds. So let me rerun the app and let that bundle the app for the simulator and regenerate the JS bundle that will ship with the application. And then we'll highlight what that'll look like to then release an update to it. So first and foremost, now that the app has been deployed, let's come back and look at the Xcode console, where we can see that the CodePush plugin is notifying us that it was checking for an update and that there was not any updates available. And that was triggered by this call to sync. At the moment we added that to our JavaScript, at this point, anytime the root component will actually be mounted, it will immediately sync with the CodePush server to see if there's any updates available. So we can also highlight that if we come back to the CodePush CLI, we can say deployment history, math facts, staging, and see that there are in fact no releases. So what we want to do is let's actually make a change and release that. So if we come to our home screen component, and let's just say that we want to change some text to be a little bit more clear. Instead of points scored today, we'll say total points scored today. So once we've made that change, if we come back to the CodePush CLI, we can say release React, name of the app, the platform we're building for, and in this case, we'll just say make it a dev build. And what that will do is automate the generation of the new React JS bundle for us, upload that to the CodePush server, and then make it available for all users. So if we come here and now look at the history again, we'll see that now we have the release that we just made a few seconds ago that has not had anybody actually install it yet. So if we come back here and we kill the app, actually we refresh it, I apologize, you'll notice that now we get an update is available because we just released it. Now, we didn't make it mandatory, which is why the user is able to ignore it. Once again, if we come back to the CLI, we can see that the presence of the update was logged, but in this case, the user canceled it. So if we come back and refresh again, update is available. This time we'll install. If we look at the Xcode console, here we see that the download happened, here's the progress, and that it alerted us that the update will be available on the next resume, which is exactly when we chose to. Which is why, even though now the download is complete, we still do not see the total points scored text that we put in there. So if we switch away from the app and then come back to it, you'll notice that now the app was reloaded and displays the total points scored text that we changed, precisely because we asked the CodePush SDK not to install the update until the user resumed, which we just did. So if we come back to the CLI and rerun our history again, what you'll see is now we're getting install metrics on our updates. So in this case, we can see that we have one unique user on this app and that 100% of the users are currently running this version of the app, which, as you can expect, makes sense because it's just me. Now let's make another change, this time impacting an image, because CodePush is useful for not just JavaScript changes, but also any of your assets. So what we're going to do is we'll just simply rotate this icon of the play button. So if we come into the components folder, open it up, and we'll just simply rotate it left, which makes 0 sense for a play button, but it'll help us illustrate the point. So once again, we'll just say release React. This time I'm going to make it mandatory. So once I release that, it's going to pick up the change to the button, release it to the server, Once again, let's take a look at our history. We'll see that there's our second release. This time it is mandatory, but nobody's installed it yet. So let's come back to the app, restart it. Notice we get the update available, but this time we don't have the ignore button. And the reason is because we flagged this update as mandatory. Additionally, a mandatory update is going to automatically install immediately by default. So the moment I hit the continue button, it's going to reload the app instead of waiting until the next resume. Now that's a configurable option, but by default, the CodePush SDK will automatically treat mandatory updates as being critical and therefore will enforce them immediately. But notice that here is the icon change that we made. So that's illustrating that CodePush is useful not just for releasing updates to JavaScript, but also to your icons. Just to also drive home the point, let's go back to our CLI, and you'll notice that now two things happened. We see that 100% of our users, which in this case is just me, are now running the V2 update, and that nobody is on V1. And this is because CodePush is able to see that I transitioned from V1 to V2 once I installed the second update that was in this case mandatory. So in order to make it more reliable to release updates via CodePush, we have this concept of deployments, which allow you to have multiple copies of your app in flight at any given time. And in fact, I didn't explicitly mention it, but what we've been using for this demo so far is the staging deployment, which is why when I was running the history command, you noticed that I was specifically saying, show me the history of releases for the staging deployment of the MathFacts app. And in fact, if at any given time you want to understand what deployments an app has, you can say deployment ls and then the name of the app. So in this case, we'll see there's two deployments that are created automatically for you whenever you create a new CodePush app, production and staging. You can create any number of new deployments. You can delete any deployments that we create. You can rename these from staging to foo. The name is just a placeholder. It's not special in any way. But what we're indicating here is that what we've been doing is releasing updates to a staged environment as opposed to releasing them to production. And to that point, you'll notice that production actually doesn't have any updates released to it at all. So on the same simulator, you'll notice that I actually have two versions of the MathFacts app. The purple one is staging, which is what we've been running, and then the MathFacts app is production. And so the staging one we've updated, and we'll just go ahead and kill this. We're done with that. And you'll see that it is ahead by a few changes, right? We made this text change to say total points scored today. We also made this change to the icon. But if we come to the production version of the app, you'll notice that it does not have either of those changes, and that's because we haven't made them available to production users. So with CodePush, the way that we recommend doing this is do all of your releases to staging, test that they're good, and then do a promotion from staging to production. And so the way that'll look is if we say CodePush, promote, the name of the app, MathFacts, and we're going to promote the latest release from the staging deployment to production deployment. So the moment we do that, now let's go ahead and say deployment history, MathFacts, production. And what we'll see is that, let me give this a little more space, there's a single release on the production deployment that has no installs, but we also can understand easily that it was promoted from the staging deployment V2 release. Now everything about the release that was set in the staging deployment is also true in this case for the production deployment. So you'll notice that we had marked that as mandatory. The app version it was targeting was 1.0, and then the code that is part of that release will also be the same. So let's go ahead and kill this app and simulate a new user running it for the first time. So you'll notice that the moment we opened it, that the app discovered the update and immediately refreshed. Now the reason it did that is that because in our production version, we were not displaying the update dialog. So you can imagine what we were doing was equivalent to this, where we just removed this update dialog true part. And this is something that we recommend for a lot of apps that are in production. It can be obtrusive to end users to display the dialog. And so what we tend to recommend for public consumer apps is what's called a silent install. And what that is that when an update is available, you download it silently, and then you can determine when you want to actually install it. So in this case, the app was configured to install on the resume, but because of the fact that it was made mandatory, it did it immediately. So if we come back to the history for production, once again, just like we saw with staging, you'll see that one of our users are now using this release on production. So what's cool about this workflow is that, as you can see, and let me just go ahead and kill the app and rerun it just to kind of drive home the point that this is persisting, this update that we released. But what's cool about this is that you can build multiple versions of your app and install them on the same device, and then use CodePush to rev them individually. That way you can iterate very quickly in your dev or staging environment, and then as soon as you're comfortable with an update, you can then move it over to production and make sure that your end users get something that has been totally battle tested. So the last thing that I want to show is a feature that we've built into the CodePush SDK to help safeguard you from accidentally releasing a bad update. And the reason that we did this is because we've got a lot of feedback from folks that while CodePush is awesome in that it enables you to have a very agile release cycle, it might almost be too easy to release updates into production, and therefore it can be easy to release broken builds. Now, to offset that, as I just illustrated, we absolutely recommend the workflow of releasing to staging, testing that bits, and then promoting to production. But we recognize that there will be times when people will release directly to production and therefore might not have fully tested it out before it gets to your end users. And to safeguard you there, we actually have a feature in the plugin that will automatically roll back bad builds. So to illustrate that, let's come back to our code and let's actually inject an artificial crash. So we're going to call a function that does not exist. And in React Native, when an unhandled exception happens in JavaScript, the default behavior is to crash. So let's do that. Let's come back to our CLI, and we're going to say release React. The name of the app is MathFacts. The platform is iOS. We'll say it's a dev build. This time we're going to say, and we'll make it mandatory, because let's say, oh, this is a super critical fix, and we got to get it out. And then we're going to say the deployment name is production. So here we're doing kind of a no-no. We're releasing a change directly to our production users without having actually tested it, which is not great, which in this case we know is going to be bad because we actually injected a crash. So if we say history yet again, we'll see the release. So I'm going to kill the app, and actually I'm going to come to staging, and you'll notice that nothing happens, and that's because we didn't release to staging, we released directly to production, which is what the no-no is. So let's kill the staging app, let's open up production, an update is available, and it just crashed the app. Now you might be asking, why did we see the update dialog in the production version after we didn't see it the first time? And the reason is because the update that we actually pushed to production included a change to the call to codepush.sync, which decided to show the dialog, which is interesting because you can actually use CodePush to update your update experience. But the thing that we want to showcase is the fact that the app just crashed, which is really, really bad. So if we come back here, look at the history, you'll see that there's one pending install for the latest release that we just shipped. And the reason it's pending is because CodePush doesn't know if it's successful or not. So let's go ahead and open this app yet again, and you'll notice something interesting. It's not crashing. And the reason is because the moment that we ran the app the second time, the CodePush SDK recognized that the app had previously crashed because of a bad update, and therefore it rolled the user back to the previous one. So you'll notice we still see the total points text, we still see the icon change, so we didn't get rolled back to the bits that were shipped in the binary, but the user is now completely unblocked. If we come back to the CLI and run our deployment history, you'll see that I can actually identify that a rollback happened locally. This way, as a developer, even if I choose to release an update that maybe wasn't as fully tested, or there definitely are exceptions that can be different on different devices, I can immediately identify whether there are any issues happening with the update that I shipped. So in this case, you can notice that even though there's a newer update, that still 100% of my production users are on V1, because after attempting to update to V2, it failed and rolled me back to V1. Now what we can do here is we don't want to have our users continue to install this update and continue to crash. Even though the next time they run the app, it'll roll back, it's still not a great experience for that to happen. And so what you can say is code push, rollback, the name of the app, which in this case is MathFacts, and then the name of the deployment, which in this case is production. So it'll ask us if we're sure, we'll say yes. And what that's going to do is, if we look at the history, it's going to create a new release that contains the exact same code and metadata of the previous release. And the reason that this is beneficial is we've effectively just shadowed away this bad update for any new users. So if a second user or a second device for the same user now runs and synchronizes with code push, they will not get the one that was broken, they will get this one. But if the user was already running V1, they will not get any updates, because code push will be smart enough to actually recognize that this is equivalent to V1, and so if they're running V1, they will not need to get V3. So that's basically a whirlwind tour of code push, showing the basic capabilities, updating assets in JavaScript, using staged deployments, as well as the rollback protection that helps give you confidence that this type of release agility won't completely introduce volatility into the quality of your product. Hopefully the demo illustrated how code push can be used to release updates to your React Native app in a much more agile way. However, the demo only scratched the surface in terms of the capabilities that code push actually enables React Native developers to use. I showed iOS support primarily in the demo, but we also have full support for Android as well. We also have support for team sharing so that multiple developers can access and release to the same application, as well as flighting releases, so if you want to test out a new update to only a percentage of your users, you can do that too. And many, many, many more things. So if you're very interested in code push, I would encourage you to check out the service, give it a try, and do let us know if there's anything that we're missing. So if you'd like to find out more information about code push, I would encourage you to check out our website, which is going to include a ton more documentation on the service, the CLI, as well as the SDKs. In addition, we also have a lot of sample apps that can help make it easier to get started. If you have any questions or any comments or feedback or advice on how we can make the product as best as possible, please don't hesitate to email me or hit me up on Twitter, as well as our team is always in the Code Push channel on the React Native React to Flux channel. So we hope that you find value in Code Push, and we look forward to hearing any and all feedback you may have. Thank you very much.